بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 7.4 integrating rational functions using partial fractions. Here write out the form of the partial fraction decomposition of the function. Do not determine the numerical values of the coefficients. So to write the decomposition, we need to factor the denominator. X squared plus x minus 6 can be factored into x plus 3 times x minus 2. Okay, 3x minus 2x is x, yes. So we have two linear factors. So the decomposition would be a over x plus 3, the first linear factor, plus b over the second linear factor. Here, if we take x square as a common factor, so we will have 1 plus x square. Now, x square is a linear factor repeated twice, and 1 plus x square is an irreducible quadratic factor. So for x square, I need x, fraction for x square, and there is a fraction for the irreducible quadratic factor. Here I put a, here b, and here cx plus d. If you have any problem, please study the lecture before you come to the exercises. The previous video. All right, how to factor here? I can take x as a common factor. And when I take x as a common factor, I'll have x squared minus 3x plus 2. And I can factor this into x minus 2 times x minus 1. All right, yeah. So I have three linear factors. So each one of them would be in a denominator of a fraction. And I put a, b, and c. Here it is already factored. Good. I have x linear factor, so a over x plus 2x minus 1 is a linear factor repeated twice. So 1 for 2x minus 1 and another fraction where the denominator is 2x minus 1 to the power 2. Okay, and now this is an irreducible quadratic factor. X squared plus 1 is quadratic and it's irreducible. It has no real zeros. And it is repeated twice. So I put x squared plus 1 to the power 1 in a fraction and x squared plus 1 to the power 2 in another fraction. I have dx plus e here and fx plus g here. Any irreducible quadratic factor, you put degree 1, okay, polynomial of degree 1 in the numerator. Let us factor the denominator. Difference of two squares can be factored into x squared minus 1 times x squared plus 1. And then x squared minus 1 can be factored into, again, using difference of two squares, x minus 1 times x plus 1, and we have x squared plus 1. So this is the factored form of x to the power 4 minus 1. I have x minus 1 linear factor, x plus 1 linear factor, x squared plus 1 irreducible quadratic factor. So a, b, cx plus d. Now question 6, I have x squared minus 4, but look to the numerator. In the numerator, I have x to the power 6. Well, I cannot write the decomposition because this is an improper rational function. Degree of the numerator is greater than the degree of the denominator. So the first thing to do is to use long division. X squared divided by x to the power 6 divided by x squared is x to the power 4. Multiply x to the power 6 minus 4 x to the power 4. Change the signs and add. I will have 4x to the power 4. Divide by x squared. I have 4x squared. Multiply minus 4 times 4. Change the signs and add. I'll have 16x squared. Divide by x squared plus 16. Multiply minus 64. Change the signs and add. I'll have 64, and that's the remainder. So I can write this as x to the power 4 plus 4x squared plus 16 plus 64 over x squared minus 4. And now x squared minus 4 can be factored into x minus 2 times x plus 2. So I can write this as x to the power 4 plus 4x squared plus 16 plus a over x minus 2 plus b over x plus 2. X minus 2 times x plus 2 is the factored form of x squared minus 4. So this would be the decomposition. Evaluate the integral. Well, immediately I will call this I, and 5 over x minus 1 times x plus 4 would be equal to a over x minus 1 plus b over x plus 4. To find a, I cancel x minus 1. I replace x by 1. 1 plus 4 is 5. 5 over 5 is 1. So a is 1. To find b, I cancel x plus 4. I replace x by negative 4. Negative 4 minus 1, negative 5. 5 over negative 5 is negative 1. So I would be equal to integral of 1 over x minus 1 dx minus integral of 1 over x plus 4 dx, and this is ln absolute value of x minus 1 minus ln absolute value of x plus 4 plus c. So that's the answer. Here I have, let me call this I, x minus 12. I take x as a common factor, so I'll have x minus 4. I can write this as a over x plus b over x minus 4. Now to find a, I cancel x here and replace x by 0. Negative 12 over negative 4 is 3. So a is 3. Now I cancel x minus 4 to find b and replace x by 4. 4 minus 12 is negative 8 over 4. So that's negative 2. So B is negative 2. So I would be equal to integral 3 over x minus integral of 2 over x minus 4. And the answer would be 3 ln absolute value of x minus 2 ln absolute value of x minus 4 plus c. Here I have two common factors. I leave it for you to solve it. Okay, that's easy. You can do it just as the previous examples. 5x plus 1 over 2x plus 1 times x minus 1 would be equal to a over 2x plus 1 plus b over x minus 1. Let me do it. All right. To find a, I cancel 2x plus 1 and replace x by negative half because that's the 0 of the denominator. 5 times negative half plus 1. That's negative 3 over 2 over negative half minus 1. That's also negative 3 over 2. So a is 1. To find b, I cancel x minus 1 and replace x by 1 here. 5 plus 1 is 6. 2 plus 1 is 3. 6 over 3 is 2. So b is 2. And I would be equal to integral of 1 over 2x plus 1 plus integral of 2 over x minus 1. Of course, if you add these two fractions, you will get this one. So the integral of 1 over 2x plus 1 is ln absolute value of 2x plus 1 over 2. Do not forget the derivative of 2x plus 2 ln x minus 1 plus c. Definite integral. Well, 2 over 2x squared. Let me factor the denominator. Let me call this I. Now factoring the denominator, 2x times x plus 1 plus 1. So I have yeah, that's the factored form. I can write it as a over 2x plus 1 plus b over x plus 1. To find a, is it the same? No. Okay. To find a, I cancel this and replace x by negative half. Well, 2 over negative half plus 1 is positive half. And 2 over half is 4. So a is 4. Now to find b, I cancel this and I replace x by negative 1. Negative 2 plus 1 is negative 1. 2 over negative 1 is negative 2. So I is equal to integral 4 over 2x plus 1 dx from 0 to 1 plus integral from 0 to 1, or let me say minus because b is negative 2 I can take 2 out. I can leave it inside. It's okay. 1 over x plus 1 dx. So 4 ln 2x plus 1 over 2, the derivative of 2x plus 1 from 0 to 1 minus 2 ln x plus 1 from 0 to 1. 4 over 2 is 2. If I replace x by 1, 2 plus 1 is ln 3. If I replace x by 0, I have ln 1, which is 0. So it's 2 ln 3 minus 2 times. If I replace x by 1, it would be ln 2. If I replace x by 0, it would be ln 1, which is 0. So that's the answer. You can leave it like this. You can write it as a single logarithm, ln 3 to the power 2, which is 9, over 2 to the power 2, which is 4. Both are correct. This is the exact answer. Notice that the numerator is greater than, the degree of the numerator is greater than the degree of the denominator. So I have to use long division. Plus x divided by x is 1. So I have 1. The remainder is 1. So this would be equal to integral x plus 1 dx plus integral, the remainder, which is 1, over x minus 1 dx. I leave it for you to continue and find the answer. Same. The degree of the numerator is equal to the degree of the denominator. So we have to use long division. 3t divided by t is 3. Negative 2 plus negative 3 is negative 5. So this is equal to integral 3, which is the divisor, dt, which is the quotient, sorry, dt, plus, or let us say minus, because the remainder is negative 5. So negative 5, integral of 5 over t plus 1 dt. And the integral is very easy. It's 3t minus 5 ln t plus 1 plus c. Well, 4y squared minus 7y minus 12 over would be written as a over y plus b over y plus 2 plus c over y minus 3. We can find a if we cancel y here and replace y here as 0. Negative 12 over 2 times negative 3. 12 over 6 is 2. So a is 2. I can find b if I cancel y plus 2 here and replace y by negative 2. So 4 times negative 2 squared is 4 minus 7 times negative 2 minus 12. Okay, this is 18 over y is negative 2 times negative 2 minus 3 is negative 5. So negative 2 times negative 5, it would be 10. So B is 9 over 5. Let me check it again. Yeah, correct. Now what about C? I cancel y minus 3 and replace x by 3 here. 3 square is 9. 4 times 9, 36. Minus 7 times 3, that's 21, minus 12. The numerator is 3. 3 plus 2 is 5 times 3, that's 15. 3 over 15 is 1 over 5. So C is 1 over 5. So this integral I would be equal to A is 2 times integral from 1 to 2 of 1 over y plus B is 9 over 5 times integral 1 over y plus 2 from 1 to 2. C is 1 over 5 times integral 1 over y minus 3 dy from 1 to 2. I leave it to you to continue the question, okay? Just to len y and replace 1, 2 plus 9 over 5 len y plus 2 and replace from 1 to 2 1 over 5 len y minus 3 and replace from 1 to 2 and just find the final answer. Let me do it. Len 2 minus len 1 is 0. Len 4 minus len 1 is 0. Plus 1 over 5. 2 minus 3 is negative 1. Absolute value of negative 1 is 1. Len 1 is 0. Minus len 1 minus 3. Absolute value of negative 2 is 2. So len 2. So this minus, I can take it outside and I remove the minus and the parenthesis. So this would be the answer. And since I have 2 len 2 and 1 over 5 len 2, I can even simplify more. 2 is 10 over 5 minus 1 over 5. So that's 9 over 5 len 2 plus 9 over 5 len 4. If you want, you can do more than that, but this is enough in my opinion. Well, now the first repeated linear factor. So x squared plus x plus 1 over x plus 1 square times x plus 2 would be equal to a over x plus 1 plus b over x plus 1 to the power 2 because it's repeated plus c over x plus 2. And I can find b and c because I have x plus 1 square here and x plus 2 here. So I can find b by canceling this and replacing x by negative 1. So I'll have 1 in the numerator. Negative 1 plus 2 is also 1. So B is 1. I can find C by canceling x plus 2 and replacing x by negative 2. Negative 2 squared is 4. Minus 2 plus 1, that's minus 1. And negative 2 plus 1 is negative 1 squared, that's 1. So C is 3. And now I need to find A. And to find A, I have to multiply by LCD. And the LCD is this one, x plus 1 squared times x plus 2. So I will multiply both sides by x plus 1 squared times x plus 2. So I'll have x squared plus x plus 1 equals A times, I have x plus 1 here. So when I multiply by the LCD, I'll have another x plus 1 and x plus 2 plus B is 1. And when I multiply this by the LCD, x plus 1 squared cancels, and I'll have x plus 2. There is no need for parentheses. So just write it x plus 2. Plus C is 3. And there is x plus 2 here. So I'll have x plus 1 to the power 2 in the numerator. And now I can find A easily by just replacing x, for example, by any number. For example, 0. Okay. Or you can find it by equating the coefficients. But it is easier here to replace x by a number. So the left-hand side would be 1. The right-hand side 0, 0. So 2a plus 0 plus 2 plus 0 plus 1 square is 1 square. 1 times 3, 3. So 2a is equal to 1. Keep 1 there. This is 5. Take it to the other side. So 2a is negative 4 and a is negative 2. So this integral, I can write it now as a is negative 2. So negative 2 integral from 0 to 1, 1 over x plus 1 plus b, and b is 1. So plus 1 over x plus 1 to the power 2 from 0 to 1. C is 3. So plus 3 integral 1 over x plus 2 from 0 to 1 dx. And that's it. Only this integral now. It is easy to find this integral because you can just call u equals x plus 1, usual substitution, and du would be dx. So it would be u to the power negative 2, and the integral it would be u to the power negative 2 du, and the integral would be negative 1 u to the power negative 1 over negative 1, or negative 1 over u. So I'll have negative 2 ln absolute value of x plus 1 from 0 to 1. And here I will have negative 1 over u, which is x plus 1 from 0 to 1. And here ln x plus 2 from 0 to 1. And I have here negative 2 ln 2, 1 plus 1 is 2, minus ln 1 is 0, minus. If I replace x by 1, I have half, and then minus, so that it would be plus 1 over 1, that's 1. And here plus 3 len, replacing x by 1, I'll have len 3, and then minus len, replacing x by 0, I'll have len 2. So the final answer would be 1 minus half is half, negative 2 len 2, plus here also minus 3 len 2, so I'll have minus 5 len 2, and plus 3 len 3, and I leave the final answer like this. Well, factoring t square minus 1, t square minus 1 can be factored into t minus 1 times t plus 1. But I have power 2. So I will have 1 over t minus 1 to the power 2 and t plus 1 to the power 2. And I have two repeated linear factors. So a over t minus 1, b over t minus 1 square, c over t plus 1, and d over t plus 1 to the power 2. And now I can find b by cancelling t minus 1 square and replacing t by 1. 1 plus 1, 2, to the power 2 is 4, so b is 1 over 4. I also can find d by cancelling t plus 1 square and replacing t by negative 1 here. Negative 1, negative 1, negative 2 squared is 4, so d is also 1 over 4. Good. So now I need to find a and c. So I will multiply by the LCD. The LCD is t minus 1 to the power 2 times t plus 1 to the power 2. So I have 1 equals. When I multiply the left-hand side, all the denominator will disappear. I'll have 1 equals a times t minus 1 is gone. So I still have another t minus 1 times t plus 1 to the power 2. b is 1 over 4. T minus 1 square will be gone, and I'll have t plus 1 to the power 2. C times t plus 1 will be gone. I have another t plus 1 times t minus 1 to the power 2. D is 1 over 4. T plus 1 square will be cancelled, and I'll have t minus 1 to the power 2. Now I can here either expand all of this and equate the coefficients, and this seems long for me, or I can just replace t by two numbers. So, but not 1 and negative 1, because 1 and negative 1 will not give me anything. So replace t by 0. So 1 would be equal to 0 minus 1, 0 plus 1. This is 1 squared. Okay, no problem. So negative 1, negative a. 0 plus 1, 1 squared. So plus 1 over 4. 0 plus 1, 0 minus 1, negative 1 squared is 1, 1 times 1 times c. 0 minus 1, negative 1 squared is 1, so plus 1 over 4. So I have an equation, negative a plus c equals half. If I take half to the other, 1 over 4 plus 1 over 4 is half. Take it to the other side, 1 minus half is half. So this is equation 1. Let me replace t by 2, for example, okay? So 1 is equal to 2 minus 1 is 1. 2 plus 1 is 3, squared 9. So I have 9a. 2 plus 1 is 3 squared, 9 over 4. 2 plus 1 is 3, and 2 minus 1 is 1, so 3c. 2 minus 1 is 1, squared 1, so 1 over 4. So I have an equation 9a plus 3c equals 9 over 4 plus 1 over 4 is 10 over 4. So in the other side, 1 minus 10 over 4. And 1 minus 10 over 4 is negative 3 over 2. So I have these two equations and I need to solve them together to find the values of a and c. Well, I will multiply the first equation by 9. So I'll have negative 9a plus 9c equals 9 over 2. And keep the second equation as it is. Add 9 plus 3, 12c. 9 minus 3 is 6 over 2. That's 3. So c is 3 over 12 or 1 over 4. So from the first equation, negative a plus c, which is 1 over 4, equals 1 over 2. 1 over 2 minus 1 over 4 is 1 over 4. So a is negative 1 over 4. So I have a, c, and I found d and a and b. So I can write I as a over t minus 1. A is negative 1 over 4. T minus 1. So this is the first partial fraction. Plus b is 1 over 4. T minus 1 to the power 2 dt plus c over t plus 1. And c is 1 over 4. Finally, plus d, which is 1 over 4. And you can continue the answer. It would be negative 1 over 4 ln absolute value of t minus 1 plus. Notice that we can write this t minus 1. We just solved the question like it here, this one, okay? X plus 1 squared. This is exactly the same. It would be t minus 1 to the power negative 2. The integral would be negative 1. So negative 1 over 4, 1 over t minus 1. All right. Plus 1 over 4 ln t plus 1. And this is similar. Negative 1 over 4, 1 over t plus 1 plus c. Here I have one linear and one irreducible quadratic factor. So this would be equal to a over x minus 1 plus bx plus c because it is an irreducible quadratic factor. I can find A by cancelling x minus 1 and replacing x by 1. 1 plus 9 is 10, 10 over 10 is 1, A is 1. Well, now I need to multiply by the LCD. And the LCD is x minus 1 times x squared plus 9. Multiply both sides. So 10 would be equal to A is 1. When I multiply x minus 1 by this, I get x squared plus 9. Okay. I mean, I have 1 over x minus 1, and I'm multiplying by x minus 1 times x squared plus 9. So these will be cancelled, and I'll have x squared plus 9 times 1. Also, bx plus c would be multiplied by x minus 1, because x squared plus 9 would be cancelled with x squared plus 9. If you have any problem with this, it's easy. Try to do it, please, or try to see the lecture. Okay, that's it. So I can take x squared plus 9 to the other side. So I'll have negative x squared. 10 minus 9 is plus 1. And I can expand this easily. Bx times x is bx squared minus bx plus cx minus c. And then I can write it bx squared. And I can take x as a common factor from here. So I will have negative b plus c times x minus c. So equating the coefficients, coefficient of x squared here has to be equal to the coefficient of x squared there. So b is negative 1. And negative c equals to 1. So c is negative 1. And just for confirmation, the coefficient of x in the left-hand side is 0. So negative b plus c should be 0. But b is negative 1. So negative negative 1 is 1. C is negative 1. 1 minus 1 is 0. That's correct. So everything is fine. So I can write I now as 1 over x minus 1. What is b? B is negative 1. Negative 1 times x, or just negative x. And c is also negative 1. X squared plus 9. And now this would be ln absolute value of x minus 1. And this integral, I will divide this integral into two integrals. So it would be negative x over x squared plus 9 minus integral 1 over x squared plus 9 dx. Because now I can solve this by substitution, because the derivative of x squared plus 9 is 2x. And I can solve the last integral by tan inverse. I have a formula for tan inverse. So the final answer would be ln absolute value of x minus 1 and negative half. Now this would be du over u. So the integral is ln u, or x squared plus 9. And now a squared is 9, a is 3. So the integral would be negative 1 over 3 tan inverse x over 3 plus c. And please check the formula in the lecture. I think this is enough for this time. I will stop here and I will continue this section, the exercises, in another part.